So what are if-else statements? If you want to create hold on, let me go back, see if that question. All right, I don't see another question. Gave me a notification though. So if-else statements, basically, you give a condition. In this case, the example I'm showing is when world.df human development index 2011 is greater than the median, which I calculated myself. I'll show you in a minute. When this value is true, it will return the first value. When this value is false, or this rule is false, it will return the second value. So the first value is always true, and the second value is always false. And you can put any rule that you want here. So this world.df human development index, I could put below a specific value, or if I had a categorical variable, if we could put in quotes here some other value. So yeah, okay. Maybe I am. Nope, I'm not muted, so I apologize. I don't know why I can't hear you guys.
How about now?
Yeah, totally weird. Okay, so
Michael, can you hear me?
We have that with our
can hear
if-else
you.
statements.
Please.
So this is really useful if
Yeah,
you want to
Luis,
create
can hear
new variables that are based on
Okay,
other
yeah.
variables.
Seems that her problem is on
So
her end.
I'm going to
Okay.
go in and show you how
It's
this
gotta
works.
be on her end.
All right. So in this case, I'm going to find the median human development index. So remember that if you have missing data in your data set, which I'm almost positive in that variable we do, you have to put na.rm equals true. That means na remove equals true. So let's put that in. Our median value, if we print it, is 0.698. So just to show you what it would look like if we got rid of this would create a problem for us. It'll return NA if we don't have that NA dot remove equals true when there's missing data. So with all the statistics functions, this seems to be how it works, or most of them. So there are two if-else commands, if-else and if-else. I usually use this one. In this case, until you start pairing it with dplyr, it's going to work exactly the same way. So this is the one I show in my slides. So we are using world.df, and we're setting a new variable or creating a new variable called human HDI.level. So this is what I would consider human development index level. So this is our new variable that we are creating. So the way that you use the if-else function is the first thing that you put in your function is a rule. So world.df human develop index 2011 is greater than the median, which we already have calculated to equal 0.698. So within that, so this is our rule. Then the next thing that we want to put in here is the value that we want to return if our the rule is true. So the high will be put here. If the value is false, it will return low. So we will create that just so we can see. And it says table of extent 0, which means I did something wrong. HDI level. First thing I'm looking for is typos. I have an idea that this might be it. Nope. All right, that's odd. This worked last night when I did it. Let's see if I miss running a piece of code. Okay, so I must have missed running one of these pieces of code, and then this depended on that value. So That's why when I give you anything, you want to run all the code, and I didn't follow my own advice. So now it's working. So we have returned 93 values here. So 93 high values and 94 low values. I'm gonna go in here real quick. I think this is an important piece of information to have. So you'll see our human development index here is missing. So you'll notice that when something is missing, it returns missing. It doesn't return low. So as you know, we made that rule. And then when that rule is true, it's high. And when it's false, it's low. But that excludes missing values. So I think that's something that you would need to know in this case. So keep that in mind when you're running it. So before I move on to case when statements, are there any questions? I can put in the chat. You can put in the chat. I'm not sure why I can't hear you guys. Okay, I think we're good to go then. All right. So this is something that I didn't teach the first time around because it's from the dplyr package. But the way that I showed it the last time, in order to do something that has more than two values that you want to create, if you just use the if-else function, you have to do these nasty nested statements that just look terrible and they're very confusing. They have a lot of parentheses, which makes them easy to screw up. And this is just, even though it's in the dplyr package, it works very similarly. And I think that this is better to just go ahead and teach this one instead of the base R version. So the other one is not very useful, or it's very frustrating to use. So case when statement is, if you are a SQL user, it works just the same. So it's basically when you want to use or create a variable with rules like we did with the if else, but that it has more than two levels here. So actually this should be 3+, so 3 or more levels. So if you have 2 levels, you would use the if else function here. So if you have more than that, in this case, we have low, middle, and high. We would want to use that. So I'm just going to go into the code and show one thing real quickly. So I am creating this three-level, it's a 3-level conditional variable. So in this case, am finding the quantiles. So this would be a way that you could make high, medium, and low. So for our Human Development Index 2011, I found the percentiles, 33rd percentile and the 66th percentile. Hold on, I have to sneeze. Or not. Okay, so we have our first value, the 33rd percentile. This quantile version, quantile function will return this 33rd percentile. It will also return as its second value, this 66th percentile. And remember, with all the statistics functions, you need to use na.rm equals true. So this will be making, with the same variable, a very similar variable, but a little bit different. So when I do the quantile, let's print it. Our first value is 0.61. Our second value, or the 66th percentile, is 0.76. So we will use that. We are going over indexing next week, but when we do this, it means it's going to return the first value. And when we do the second value, that means it's going to return the second index value. So just keep that in mind when you're using it. I'm going to go into the questions. Okay. So I created this. It's our 33rd percentile and our 66th percentile, and we'll learn more about it this week. But when I write this, it's referring to the first value in our vector, and this is our second value in our vector. All right. So that gives you the background information for me to show you exactly how this works. So just remember what I said before. This is our 33rd percentile always, and this is our 66th percentile. If you want to know more about indexing, the next introductory class will teach you this. You could also put just a hard-coded value in here. I've talked about this before, but I do not recommend that. The reason is because say you created this variable, you put a hard-coded value here, like 20, and then you used 40 for this one. Well, when you created that variable, you're going to have really uneven groups. Say you did that. The chances are, once you see the results, you might want to change that. But when you hard code it, you'll have to go in, change this value, and this value, which in my experience, when you have to change something that many times, especially if you have multiple pieces of code, it can lead to errors in the way that you write it. So I recommend always doing something that's not hard-coded, which is what we did here. So say if I wanted to change this to the 44th percentile, it would change this value, and we wouldn't have to change anything down here. So in general, in data science, your bosses will think that you should do it one way. They'll see the results and say, that really didn't make sense. Change it to X. And when you do it this way, it's a very easy fix. When it's not, it carries downward and you have to change multiple values. So that's why I recommend using something like the quantile function. You could use mean, median, anything having to do with that. So in this case case one statement, similar to SQL if you've used it, you have your first rule here. So the first rule says that the human development index is less than the 33rd percentile. That's equivalent to this value. And if that value is true, it's going to return low. So the next thing, if this is false, it will move on to the next level. So in this case, the world.df human development index is greater than or equal to, and it's going to have that 33rd percentile. So if it's greater than or equal to this value, and at the same time, this is all one rule, the human development index 2011 is less than the 66th percentile, it's going to return middle. You'll notice that there's a tilde here. So that this, in this particular case, is how you separate the rule from what it returns. And then each condition has a comma after it. And that separates the different levels of your variable that you're creating. So I put 2 rules for this second one. And if both of these statements, because I put and here, if both are true, it's going to return middle. And if both low and middle, if both of those are false, it's going to come down to the last rule here. So if world.df human development index is greater than or equal to that 66th percentile, it's going to return high. So instead of having to do multiple nested if-else statements, this is going to do the exact same thing. So I'll go into our code and show you how this creates. So I called this human development index level 3 since there are 3 levels. So I'm going to run that case 1 statement, and we'll see what it shows. So there is always, you would think that when I did use the quantile function that I would get equal groups. The reason that I don't in this case is because there are duplicates in our data. So probably the high value, there were, say, 2, there were maybe 2 duplicates twice. And so that there's going to basically be ties, and there will be more in the high value. So keep that in mind, especially when you're using something that's has integers in it, you're going to run into that problem. So we are showing here that we have 62 low values, 61 middle values, and 64 high values. How would you been using arbitrary numbers? Sure, I will show you that. So I'm going to show this with an if-else statement just because it is a little easier to write. So show this example here with hard-coded numbers. So in this case, I'm going to do this summary just so we know what the range of our values are for the world.df. We would want to do human development index. Okay, so this allows me to choose an actual value that makes sense. So say instead of doing the median, we wanted to do the first quartile, and we wanted to hard code that. So let's change, first change the median. Let's just say 52 since 0.522. That value, let's try that. So if it's greater than this 0.5522 number, it's going to return high. And if it's lower, then it's going to return low. I'm going to make this HDI level test. So that's going to return. And then we will do instead table world.df HDI level test. Now you see there are more high values because this was a lower number than low values. So it works exactly the same way, but instead of an object name, we just put a value there instead. So hopefully that answered your question.